Koshrai Agricultural Experiment Station, Cooperative Research and Extension, College of Micronesia FSM welcomes you. The Agricultural Experiment Station is the only North Pacific regional facility for multiplying the planting material through tissue culture in bulk quantities and is actively engaged in plant biotechnology research. The station also plays a vital role in germplasm conservation of economically important staple food and traditional medicinal crops. The station is engaged in vitro multiplication, conservation, and distribution of elite and disease-free seedlings. The station is financially supported by the United States Department of Agriculture, the FSM national and state governments, and grants from federal and international agencies. The Koshrai Agricultural Experiment Station's Plant Biotechnology Laboratory has all basic facilities for sterilization of equipment and media, aseptic inoculation and culture maintenance. The station has well-equipped, air-conditioned, capacious laboratory that involves media analysis room, media preparation room, plant inoculation room, plant growth room, greenhouse, plant nursery and demonstration plots. Planting materials of banana, taro, and sweet potato are being multiplied regularly through plant tissue culture techniques, and are provided to all demonstration plots for planting. Tissue culture multiplied plantlets are acclimatized in the greenhouse, and disease-free and elite seedlings are produced for distribution. Hybrid seeds are used to prepare papaya seedlings. In recent years, the use of acclimatized tissue-cultured plants as a planting material has become increasingly popular among the farmers due to the advantages of disease-free planting material, uniformity in growth, as well as higher yields. Acclimatized soft taro plants are being transported for planting at the demonstration plots. To cultivate soft taro, It is ideal to prepare field at least 2 weeks before planting. It should be dug 6 inches deep with a rototiller. Soft taro can be planted on ridges, in furrows, or on flat ground. However, since the Micronesian islands have less than 6 inches topsoil, it is highly recommended to prepare raised beds for soft taro cultivation. 8 to 10 inches high ridges are made and allowed to settle for 7 days, and then the tops are flattened. Soft taro plants are planted 1.5 feet apart in a row with a distance 4 to 5 feet between the rows. Sweet potatoes are planted on raised beds to provide desired depth for storage root development, and for proper water drainage. 8 to 10 inches high ridges are made, spaced 5 feet apart, and are allowed to settle for 7 days before planting. Slips taken from tissue culture multiplied and acclimatized plants are used for planting. 1-foot-long slips with at least 5 to 6 leaves are cut and planted immediately in a newly prepared field. Plants are planted 1 foot apart in a row with a distance 5 feet between the rows and 1/3 of the basal portion covered with the soil. The plants are watered immediately to establish good soil-to-root contact. To minimize external inputs as much as possible, multiple integrated activities are organized for cropping systems and swine production. Demonstration plots at the pilot site and producers' sites are developed, and cropping systems for sweet potato, taro, banana, eggplant, papaya and kangkong have been established. In a tropical climate, it is better to apply small quantities of fertilizer often, rather than to add large quantity in one treatment. This makes the fertilizer more profitable and prevents too rapid growth. Eggplants are planted in rows with a 3 feet planting distance between plants. Compost along with inorganic fertilizer is used for soil amendment and top dressing before planting, and for side dressings after planting. To minimize transplanting shock, planting is done in the late afternoon or on a cloudy day. Plants are planted in holes and only the first true leaf is left above the soil surface. Soil is pressed firmly around the root. The plants are watered immediately after planting to establish good soil-to-root contact. 1 month after transplanting, supports are placed nearby each plant to support the plant fruit load. Pruning is recommended to produce bright-colored, high-quality fruit. Only 3 branches are maintained per plant, 2 branches from the primary division of the main stalk and 1 branch below this division. All other lateral branches are removed periodically. Removal of older leaves from the lower portions of plants is recommended, and this will help in better air circulation and lighting within the canopy. Acclimatized banana plants are planted in holes 10 feet apart. The holes are dug directly into the ground. The bottom half of each hole is filled with compost and the top half is filled with soil amended with compost and inorganic fertilizer. Papayas are planted in rows spaced 6 feet apart. The holes are dug directly into the ground and are filled with soil amended with compost and inorganic fertilizer. Green organic material is source of nitrogen in a compost pile. All green organic materials are shredded while still fresh and are immediately used as green material for composting. Brown organic material is source of carbon in a compost pile. Solid swine manure is separated from the piggery effluent by using a rundown screen and is sun-dried for 2 weeks. Dried solid manure is shredded along with the dried organic material such as crop residues, and is used as brown material for composting. Aerobic process is used for decomposition of organic matters. Green and brown materials are layered alternately, and on each layer, a half-inch thick layer of finished compost or fresh and healthy soil from the forest is added as an activator. Hot composting technique is implemented to convert the nutrient-rich crop residues and swine manure into valuable compost. High microbial activities generate heat that is regulated and maintained within the required range of 140 to 158 degrees Fahrenheit in the composting pile by appropriate air circulation and proper moisture maintenance during heating phase. The pile is turned once in a week and treated effluent from the piggery is sprayed to control and maintain appropriate temperature and moisture. The heating phase gradually changes into cooling phase and decomposition occurs without much generation of heat, and temperature drops slowly to 86 degrees Fahrenheit. At the end of decomposition, during the maturation phase, the temperature drops between 68 to 77 degrees Fahrenheit and results in finished compost. Ecologically integrated and well-managed hot composting system composted the manure, spilled feed and crop residues in less than 3 months. Finished compost is showcased. Swine manure, effluent from piggery, crop residues and byproducts from farm are recycled through on-farm composting or treatment, and are utilized as organic nutrients at demonstration sites to fertilize the crops. This practice has greatly minimized the use of commercial and organic fertilizers. Compost along with an organic fertilizer is used for side dressings. Compost along with an organic fertilizer is used for top dressings. Sweet potato and kangkong leaves are used regularly to provide protein and dietary fiber to swine. During harvesting season, swine are also fed on surplus sweet potato storage roots, taro corms and banana fruit to provide carbohydrate. Vigorously growing bananas at demonstration plots have attracted much attention of local communities. Depending on the varieties and the climatic conditions, it takes 100 to 130 days from bunch emergence to full maturity and harvesting of bunches. The maturity of fruit can be assessed by change of peel color from dark green to pale green, disappearance of angularity and fullness of fingers, ringing sound upon tapping of the fruit, and complete drying and dropping of the floral remnants from the tip of the fruit. The matured fruit are harvested with a sharp knife, leaving sufficient length of peduncle for easy handling and transportation. Harvested fruit are not kept directly on the soil as it causes mechanical damage and results in spoilage of the fruit. Instead, the fruit are kept on the banana leaves spread on the soil. Harvested bunches of banana from the demonstration plots are showcased. Vigorously growing papayas at demonstration plot have attracted much attention of local communities. Eggplant fruit are harvested once they have reached sufficient size for marketing. That takes usually 3 to 4 weeks after flowering. Harvesting is done once or twice in a week by cutting the stalk with a sharp knife or clippers, leaving the calyx attached to the fruit. High-quality eggplant is firm, heavy, glossy with a desirable color, and free of cuts and scars. Harvested eggplants from the demonstration plot were showcased during State Agriculture Fair 2010 and 2011 and were awarded with the first and second prize for vegetable or eggplant category. To obtain maximum yield of sweet potato, harvesting is usually done 5 to 6 months after planting, although smaller storage roots can be harvested after 3 months of planting. Delayed digging is not advisable since excessive moisture of the wet soil can prevent digging injuries from healing, eventually leading to decay of the roots. Digging is done to remove the soil around the plant and expose the storage roots, which are then pulled out gently. Care is taken to avoid skinning and bruising, otherwise, wounds can become easily infested with microorganisms. Harvested roots are kept in baskets lined with rags to avoid scratching the roots. Roots are allowed to dry and cure before removing excess soil to prevent damages in freshly dug sweet potatoes. Curing is essential to heal the wounds and improve the taste of sweet potato. After removing the excess soil, storage roots are covered with newspaper to maintain required high humidity of 85 to 90% and are packed in boxes. The boxes are kept in shaded areas for 2 to 3 weeks where temperature is maintained between 64 to 75 degrees Fahrenheit. Harvested storage roots of sweet potato after curing are showcased. Taro is ready to harvest after 10 to 12 months of planting. Time of maturity varies with location, varieties used, soil fertility, and water availability. As harvest time approaches, the leaves turn yellowish and the petioles become short, usually less than 2 feet long. The corms protrude from the ground. Soft taro is ready for harvest when all or most of the cormels have become dormant and when the leaves have dried. Soft taro can be harvested and stored for a considerable length of time. However, the corms should be thoroughly cleaned, washed, and drained before storage. Storage under refrigerated conditions will prolong the life of the corms. Corms of soft taro harvested from the demonstration plots are showcased. Accomplishments of project activities were presented in the Soil Carbon Sequestration Conference at the University of Guam, USA, and also published in the conference proceedings. An abstract of project activities was submitted for Regional Symposium, High-Value Vegetables in Southeast Asia, Production, Supply and Demand. The abstract has been accepted and Conference Committee has invited Project Coordinator Dr. Virendra M. Verma for oral presentation of accomplishments during the conference in Thailand. During field days, participants are encouraged to learn and adopt appropriate techniques for integrated sustainable agriculture and livestock production at demonstration plots through field days and observations. This project is based on the farming philosophy that states that wasting nothing in agriculture makes good sustainable system, and the waste from one part of a farm is the input to another. Various project activities are demonstrated to workshop participants through PowerPoint presentations on how to optimize overall agricultural and livestock production by using locally available resources through an integrated technology, which employs multi-purpose crops, animals, and recycling of residues and byproducts as nutrients for animals and crops. Workshop participants are educated and trained in integrated sustainable agriculture and livestock production at the pilot site through training workshops and hands-on. Multicolored sustainable farming, composting and swine production guides were developed, published and distributed to workshop participants and other interested people. Thank you very much for your attention.